All right, so today we are going to practice our joins, different kinds of joins, inner joins, and mostly left joins. I won't really do right joins and outer joins because they're not really useful. So I'm just gonna do mostly inner joins and left joins. And basically, when do you wanna use a left join versus when do you wanna use an inner join? So this lesson is gonna be pretty chill. I'm just going to answer some of these questions and I'm going to work through it like I actually would do it in a big company. So I want to show you what my thought process is whenever I want to answer these data questions. So as you will see, it's going to be pretty hands-on and there's going to be a lot of testing, experimenting, queries. So I want to show you exactly how I work with data so that you don't need to write queries perfectly every time. You could write, just little queries like this, like select from, and then you could check playbook users. We do that a lot, just to see the first 100 rows, see what they're like. So as you can see, just with this query, you can see that not every users are activated. Some of them are not activated. So that gives you an idea of what columns can have nulls, etc., etc. All right, so let's just start answering these questions. So how many users are there? Okay, well, usually what you'll do is you'll just count the users. So we already have these 4 tables that we're going to work with: emails, events, experiments, users. We're mostly going to work with these 3. So users, I'm assuming each row is a user, as you can see, because each row has a unique ID. So that is a pretty good indication. So I'm just going to count how many there are. Okay. So as you can see, there are 18,000, almost 19,000 users on Playbook. And then one thing that I like to do, just to make sure the data is clean, I would count distinct user ID also, just to make sure that there are no duplicates in the table. Because you can never trust the data. You never know what the data engineers did. So, okay, 18,911, that is the same as the one I had before, which is good. So I trust this data. Next question. Get a list of users who are in experiments. How many of them, I didn't finish my question, are in an experiment? I think that's what I wanted to ask. Okay, so how do you do that? Well, there is a table called experiments. Okay, select star from. You could check out the data. Let's see how it looks like. As you can see, there is a user and then a date occurred at, maybe that's when we put the user in an experiment. And then there's an experiment name, I guess, publisher update. And then there's always 2 groups, a test group and a control group, right? Because usually when you do A/B testing for any one of these features that you want to write in a big, large tech company, you're going to put half the people on the test group and half of the people on the control group. And then you measure the metrics between them to see if there's actually a difference, right? That's why there's a test group and then a control group. Exactly the same way we do for medicine, I guess. Whenever we want to roll out new pills or new medicine, we always have a placebo group and a non-placebo group. Where the placebo group, you get fake medicine. You just get sugar pills. And then the other group, they get real medicine. And then we could see if the medicine actually works. All right, so let's check that the experiment group is only test group and control group, just for us to understand the table a little bit better. Yes, indeed, there are only 2 rows. Perfect. Okay, let's go back. So we want a list of users who are in experiments. How many of them are in an experiment? Okay, so there's a hard way and there's an easy way of doing it. Let's just do it with the hard way because I want to practice joins. So last time what we did was we select from the table users, tutorial.playbook users. And then what we want to do is we want to left join. Why are we left joining? Is because for users who are not in experiments, I still want to see them. Well, I guess not really, because in this question is only getting a list of users who are in experiments. So in that case, I could do an inner join because I don't care about the users who are not in experiments. So what do I want to join with? I want to join it with this table. Okay, let's give it some alias. I usually just do A and B because it's simple. Once it gets more complicated, you could give it better names, but for me, I only use A and B. What do I want to join it with? With user ID, because that is what we want to join to. Okay, I forgot the on here, on. All right, so let's just look at this real quick and see what our resulting table would look like. Aha, so as you can see, 6 of these columns are from playbook users. And then the other 1, 2, 3, 4, 5, 6. The other 6 columns are from experiments. And now I just joined them. Select star, which means I want to see all the columns. So I see all the columns from the first table, the playbook users, and also all the columns here, which represent the columns from playbook experiment. Excellent. Okay, so we did an inner join. As you can see, there are no more user number 1, 2, 3, 4, 5. There are only user 11, and then it skips all the users to user 19. As you can see, not all users are in an experiment. But here, we're just making an assumption that we're getting rows that are ordered by user ID, but it's possible that this is just unordered. Okay, so it's just a guess. Get a list of users who are in experiments. Okay, so now we have all the users that are in experiments. However, if a user is in multiple experiments, there will be multiple rows, right? Do you remember how that works? If ever the right table has multiple rows of the same user ID, even if your left table has only 1 row, it's going to get duplicated. All right, let's just double check. So now that we have this table, what we can do is we can aggregate them. So we could just count all of them. So we count how many rows there are, aka how many users, but can we do that? All right, let's check. So we're going to count star, meaning we're going to count every row. So there are 2,823 rows, but I also want to count distinct user ID in case there are users who are in multiple experiments, which is very common, which is very, very common in a social media app. But let's just see if it's, let's see what the error is. Column reference user ID is ambiguous. Aha, this is a very, very common error when you do joins. It says the user ID column is ambiguous. Why is it ambiguous? Because if you look over here, in the playbook experiments, there are columns, and then there is a column called user ID. However, if you go to playbook users, which is the other table that we're querying from, also has the column name user ID. So it does not know which one you want. Do you want the playbook users user ID, or do you want the experiments user ID? All right, well, I want the playbook users user ID. All right, so as you can see, it's the exact same number. That means in this website, Playbook, a user is only in 1 experiment. There are no users who are in multiple experiments. Okay, so how many of them are in experiment? 2,823. So a thing that I would like to do is I always double check myself because I don't trust myself. So is it true that all of them are only in 1 experiment? So we could have another way of checking that. Let's do the same query, but this time I want to count how many rows, and these rows represent experiments, okay? And now I'm gonna group by user ID, group by 1, and I want the user ID from the first table, okay? Let's run this. As you can see, there's a count. So what does the count mean? The count means how many experiments they're in, okay? So what I need to do now, well, just by looking at it, it looks pretty clear that every user is only in 1 experiment. But to make sure of that, you can order by 2, descending. So that means that if there is someone who is in more than 1 experiment, you're gonna see it at the top. That's why, because we want to order them. All right, let's run this again. As you can see, nothing changed. It's still number 1, still only 1 experiment. So that validates what I found here, where when I counted all the rows, and then also if I counted the distinct user IDs, they are equal. And the only way they are equal is if each user is only in 1 experiment, if they are in an experiment. All right, so what's the next question? Oh, are there users in multiple experiments? Well, I guess we already answered that. Let's just copy paste this one. You know, this is a good way to answer it. No. How many users are in no experiments? Okay, so what we can do is we can do the same join as before, but instead of doing an inner join, we're gonna do a left join. Why do we wanna do a left join? Because we also want the users who do not have an experiment row. They're gonna have nulls. All right, so first we're gonna do select star from tutorial.play Playbook users A, and then we left join it to tutorial.playbook experiments B. All right, on a.user ID equals b.user ID. Okay, let's just look at it for now so it's a little bit easier. As you can see, we now have the user 0, 1, 2, 3, 4, 5, 6, 7, 8. And if you go to the right, you're gonna see that, oh my God, it's all empty. Why is it empty? It's because these users are in no experiments. Okay, so now how do we count them? How do you think we can count them? Well, first, what I can do is I can segregate it. I can segregate all the users who are in an experiment versus all users who are not in an experiment. So how do I do that? Well, I could just filter it, right? What do I filter by? Well, I know that if user ID from the B table exists, then it means they're in an experiment. Then what I can do is I can just filter them out. So where b.userid is null. So that means I'm gonna keep this row, I'm gonna keep this row, I'm gonna keep all these rows except for this row. And then I'll keep all of these rows except for this row. Why? Because this user ID is not null. However, I only want rows where b.userid is null. You can do the same thing with any of the B rows. You could also just do experiment, right? It's the same thing. All right, let's run this again. So now what I would expect to see is a bunch of users, and then when you go to the right, it's all empty. It's all empty. Yep, that's right, it's all empty. All right, now last but not least, let's count how many rows, because that will determine how many users are in no experiments. Aha, voila, 16,088. Does that make sense? Because you remember how when we counted how many people are in an experiment, it's only 2,000 something, right? And then if you subtract that number to all of the users, so 18,911, subtracting 2,000 something will give you what we get here, the users who are in no experiments. So you might ask yourself, couldn't we just do that? Couldn't we just count all of them like this? And then also, so there's an easier way of doing it. So for example, here, you could just count all of the users. So the reason why I did it with the joins is because I want to teach you how to join, but there is another way of doing it where you could just also count the distinct user IDs, user ID from the experiment table. So that would give you all the users who are in an experiment, which is 2,000 something. Oops, I should count them. I mean, a little tip, usually using distinct is pretty slow. You won't find it slow here because these are small data sets, but once you work at a big FAANG company, using distinct is slower than just joining. So just a little tip. All right, so as you can see, we could have just subtracted this number from that number and you would get the results. Okay, cool. Okay, let's continue. What percentage of users have logged in at least once? Okay, so how do we do that? Well, there is a table called Playbook Events. Let's look at it real quick. As you can see, you have a user ID occurred at, that's probably when the event happened, the event type, event name, location, and device. That's a lot of information. All right, out of curiosity, I wonder how many events there are. So it has to be more than like 16,000 because there are around 16,000 users. Okay, yeah, so there's 285,000 events. So these are done by multiple users. A user can generate multiple events. Let's see what kind of events there are. Let's first look at the event type and then also the event name, and then we'll group by both of them. All right, let's see what kind of event type and event name do we have. Okay, so we have, let's order them. It's gonna be easier to see, ordered by 1 and 2. As you can see, we have an engagement type. So for example, logging in, liking a message, going on the home page, search autocomplete, search click. Wow, that's very very granular. As you can see, these are all the event types that you can get. And then for the sign up flow, there's complete sign up, create user, enter email, enter info. Interesting. Yeah, so these are all the engagement metrics, and then these are all the metrics related to sign up flow. Okay, what we care about is login. Okay, so So the question is, what percentage of users have logged in at least once? Well, we could use the trick before and we could do it really easily. So what we can do is we can select distinct user IDs and then count them from tutorial.playbook events where, so what do we want to filter by? We want to filter by event name equals login. So now we only have login events, and then we're just going to count the distinct users. So for users who have never logged in before, they will not be in this events table, okay? And then if they are, even if they logged in multiple times, we are counting distinct user ID. So you're going to see multiple of the same user ID, but because you use distinct, we're only going to count it once. So we're only going to count it once for the people who have logged in at least once. All right, select. All right, perfect. 6,612. 6,612 people have logged in at least once. Out of curiosity, I want to count the distinct user IDs within this table. It can't be more than 18,000. Okay, good. Because 18,000, we got that number from the playbook users table, which should record all the users ever. So here, it's less than 18,000 because there are some users who just didn't do anything. You have their accounts, but they never did anything on the website. So that's why they do not appear in this table. So now we want to know what percentage of users have logged in at least once. Well, what we could have done is we could have just used this number. Actually, let's record it. What is this number? 6612 divided by, we're just going to count all the users here. 18911. All right. So this is one way of doing it. You just have to do 2 queries and then you have to manually divide them. But let's try to do something cooler using left joins, and then I want the query to return the exact number, like the exact percentage. I don't want to do 2 queries and then divide them myself. I want to be cooler. Okay, so what can I do? All right, so first what I'm going to do is I'm going to select from the users table. So I'm just going to get all the users first, and then what I'm going to do is I'm going to left join it to the events. Okay, so I named this A, I named this B. Okay, I'm gonna join it on the user ID, of course, a user ID, and then also user ID. Yeah, so I join it to user ID, but what I want is I want to filter for the events that are event name login, because I don't care about all the other events. I just care about if they logged in or not. So what I'm gonna do here is I'm gonna say on a.userid equals b.userid and b event name equals login. So there's a small distinction between where and on. So on is related to the joins, okay? So what happens is I'm only gonna join rows from the table B, this table, if the user ID matches the user ID of my left table, which is users. And if it's a login event. If it's not a login event, then I'm not even gonna join it, right? So this is the join condition, okay? And then, however, imagine if you did this, where event name equals login. Okay, so why can't I do that? The reason is because when I'm gonna join, as you know, there are going to be some rows where event name does not exist, right? Because once we join the left table to the right table, we are going to get some users who have, actually, you know what? Let me just show you. So I'm gonna join like this. Sorry, I'm just gonna order it by username first, a.userid, so it's easier to see. Okay. We're gonna ignore the where part for now. Okay, so as you can see, we have each user, and then we have events. These are the events that's happening. So as you can see, the user 0 to 7, they never did anything on the website, so they have no events. User number 8, you can go look at it. What did they logged in first, then they went to the home page, they sent a message, they liked the message, they went back to the home page, and then they like a message, and then they went back to the home page. Basically, they did a lot of stuff. They view inbox. Oh wow, this is a highly engaged user. So as you can see, this user used the website quite frequently, and they live in France using the Nexus 5 device. The table looks like this now, okay? So what if I don't care about these event names, okay? Then what I can do is, like I said, filter by event name equals login. All right, so there's a mistake here, syntax mistake. The reason why is because I wrote it after order by. It should be before order by. So I have to start filtering here instead. All right, I'll run it. Okay, as you can see, the users 0 to 7 no longer exist. All right, and then if we go to the right, the only event that you have now is login. As you can see, they're all logins. So you only have logging events. However, what's the point of the left join if you're not going to get all the users that didn't do anything? So the users 0 to 7, they disappeared. Why? Because when you joined, as you can see, they don't have any event names here. So that's why when you filter by event name login, these users will disappear because they do not satisfy this event name equals login, right? But here's the thing. I do want only logins, but I also want to keep the users who haven't logged in. So how do I do that? So this is why you shouldn't use where, because you don't want to filter after the join. You want to kind of use the constraint during the join. So if you do and, as you can see, things will look very different now. When you run it, aha, I have my users now, 0 to 7 and stuff. And then if you go to the right, you get nulls or you get only login events. Perfect. That's exactly what we want. So now we still have all these users, okay? So that's the thing. If you count distinct user ID, you will see that there are 18,000 users. Oops, I don't need to order by. Okay. It's also ambiguous. A dot. Run again. See, as you can see, these errors are really easy to fix. As you can see, 18,911 users. Perfect, that's exactly what we wanted. Now, imagine if you did where, then you wouldn't get 18,000, you get a lot less. All right, these are all the users who have logged in at least once. All right, cool. Anyways, big tangent, but back to what I wanted to do is I want to get the percentage of users who have logged in at least once. So let me erase this. And then what we're gonna do is we're gonna count all the users. So distinct user ID from the A table, because the A table contains all users. And this will be my denominator. And then I'll also count distinct b.userid. Why? Because I know that all the users who have not logged in will have null on the right side of the table. Remember when we joined it? So I'm gonna count distinct b user ID for the users who have logged in. Because if they have not logged in, this will just be null, and then it will not be counted. All right, let's try this. Let's see if this works. Aha, we get 0. That is odd. Why does that happen? It doesn't seem right. Well, I already know what the issue is, and I'll just tell it to you. The reason is because this is going to give me an integer, and then the denominator is also going to give me an integer. And if you know in programming, integers are not floating numbers. However, when you divide two numbers, I technically want a floating number. So what I can do is I could just multiply by 1.0. This is a very, very common trick in SQL that you should know. Is if ever you want to calculate percentages and stuff, I just multiply by 1.0. So you transform the numerator into a floating number. And then you will get the actual percentage, which is 35%. So 35% of users logged in at least once. Awesome. And then for fun, let's just do some quick ones because we're almost out of time. Show the distribution of users on how many times they've logged in. So basically I want to see how many users logged in 0 times, how many users logged in once, how many users logged in twice, etc., etc. All right, so let's just do this. So what I'm going to do is I'm going to select the user, okay, from the original table. let's just do this join. We're gonna do a left join because we want to include people who logged in 0 times. And then we're gonna do the same join on user ID equals B user ID and event name equals login. And then what we're gonna do is we're gonna group by 1, and then we're gonna count. We're gonna count. Let's see what this looks like for now. Let's just order it by user ID also, just so that I can see. A dot run selected. Oh, I want ascending. I want to start from 1. So as you can see, it says that user 0 logged in once, user 1 logged in once, user 8 logged in 5 times. Does that sound right to you? No, it doesn't. And the reason why is because we remember that users 0 to 7, they've never logged in, but yet it still gives me 1. Why? It's because I'm counting star, which is the whole row. So what I'm gonna do is I'm gonna choose a column on the event side. Let's just say event name. It doesn't matter which one you choose, but let's see if this works now. Now it should give me null, and null should give me 0. Aha, perfect. So now it gives me 0, so it means user ID 0, logged in 0 times. User ID number 5, they logged in 0 times. User number 8, they logged in 5 times. Perfect, that works. Okay, so now that we have this, we're gonna create the distribution. So we're gonna use this whole query as a subquery now. So now this becomes a new table. Let's just call it table 1. And then we're gonna select from this whole table. And then what we're gonna do is we're gonna group by, actually let's call this as number of logins. So the number of times it logged in. Let's just run this again just to see it. So what I wanna group by this time is the number of logins, and then I'm gonna count star. And then this would represent number of users, okay? So we use this as a query. This is the subquery, which now we use it as like a separate table. And then we group by 1, group by the number of logins. So now what we're gonna get is the number of logins and then how many people logged in that many times. As you can see, people who logged in 0 times, 12,000 users, you know, because they never logged in. Users who logged in once, there are 1,900 of them, etc., etc. Yeah. And then what we can do is we can create a chart with that, and you can choose a bar chart. And then for the x-axis, we want the number of logins, and then for the y-axis, the number of users. As you can see, this is what it looks like. Lots of people create accounts, but they never log in. That sounds about right to me. In most social media websites, you can see that there's a lot of like spam or just like users who are inactive, and then it's like an exponential decay, I guess. But anyways, this is the distribution. There are just like one guy who logged in like 60 something times. That's interesting, must be a power user, but yeah. All right, back to the query. To make sure the data is clean, are there any events that are from users that are not in the users table? Okay, the reason why I asked this question is because sometimes there could be issues in the data, and also it's a great excuse for me to use a right join because it's usually not that useful, because if you could do a right join, you might as well just flip the tables from the left one to the right one and then just do a left join instead, right? For example, let's take this guy right here. For example, this query is probably the same as this query if we just swap the tables, right? It's the same thing. It's actually the same thing. The only difference is like the order. Let's see. I forgot to join them. User ID equals b dot user ID. Yeah, like this is actually the same thing. Yeah, this is the same thing, but instead the columns of events are here instead of on the right side. But yeah, same thing. Okay, so to make sure the data is clean, let's go back to the original where users was in the left side and then events on the right side of the join. So yeah, so we're gonna join to the right, and what we care about is, are there any events where the user ID is not in the playbook users table? So what am I gonna do? So I'm just gonna filter by where a.userid is null, right? Because that's what we care about. We want to know if the data is clean. Are there any events that there are from users that are not in the users table? All right, so let's do that. So we did the right join, so that means every single row of events will appear. And then if there is an event where the user ID is not in this table, it means it will not get matched. It will be assigned null. So that means a.userid will be null. Let's see if there are any. Nope, 0. So that means the table is clean, which is surprising because most social media websites data are not that clean. All right, so that's pretty much it for today's lesson, and I hope you enjoyed it. So this is usually my thought process, how I go through queries, how I write queries, and how I debug my queries. So yeah, see you in the next one.